Hello, one more time. How was lunch? It was good? Glad to hear. So, today we will talk about our new 60 gigahertz implementation, our roadmap, what works right now, and our first 60 gigahertz device wireless wire kit.
接下来我们要讲一下我们新的60G 的路由器实现，我们的路线图以及这个玩意儿是怎么工作的。
60 gigahertz was a very big project for us because it's a new frequency we have never used before. So I hope you like my presentation.
60G 设备对我们来说是一个非常大的项目，因为这是我们第一次用这个频率，然后希望你们能喜欢它。
So let's talk a bit about wireless bands. Currently, MikroTik supports 3 wireless bands.
接下来我们讨论一下无线频段的比较。现在 MikroTik 支持3种无线频段。
But for each band, there are some pros and cons. Each frequency should be used in a specific usage case.
但是这3种频段每一种都有它的优点和缺点，同时有它适用的用户案例。
Wireless isn't perfect. There are still some hurdles to overcome.
有线并不是完美的，有时候会有一些不好走的地方。
For example, 2.4 gigahertz is very crowded. It's hard to find free channel. It's hard to find channel that works great in very crowded areas.
2.4G 的缺点是，现在我们很难找到一个干净的频段去使用它，同时干扰非常多。
There are only few available channels. If you want to use 40 megahertz channels, then you will suffer for speed. If you use 20 megahertz channels, if you use 40 megahertz channels, you will suffer with interference. If you use 20 megahertz channels, you will suffer with speed.
如果你用40G 的频段，你会受到干扰的影响；如果你用20G 的频段，则会受到速度的影响。
But 2.4 gigahertz has the highest distance from other frequencies.
但是2.4G 拥有最远的传输距离。
And it can penetrate through objects, for example, walls, trees.
同时它也可以穿透一些物品，比如说墙、树。
5 gigahertz, on the other hand, has cons with dynamic frequency selection and radar detection.
5G 的频率则会有雷达检测以及雷达动态频率检测的问题。
Radar detection, dynamic frequency selection, is a very new addition to 5 gigahertz spectrum, and it still needs some work to be done to work properly.
DFS Dynamic Frequency Selection 动态频率选择是一个新的东西，我们还有一些在上面的开发要做。
Even if no radar is present, there still may be some false alarms. If no radar is nearby, there still can be false alarms about radar detection.
就算周围没有其他的干扰，我们也可能需要一些时间去使用。
Channels for 5 gigahertz are rapidly increasing. People started with 20 megahertz channels, then N standard came with 40 megahertz channels, AC with 80 and 160 megahertz.
5G 频段现在发展的非常快，最开始人们使用的是20兆的频宽，现在已经发展到40兆、80兆甚至160兆的频宽。
But due to larger channels, we can get more throughput through it, and we have more available channels.
使用更宽的频宽，我们可以有更高的速度，同时我们也可能会有更多可用的频段去使用。
With 60 gigahertz, we have to talk about elephant in room. It doesn't go very far.
使用60G 的频宽，我们这个频段的传输并不能很远。
This is actually the worst frequency for data transmission.
这个频段对于数据传输来说，可能是最弱的频段。
But due to this property, it's mostly free.
但是由于这种特点，它的频段可能会非常干净。
It provides the highest throughput, and it's relatively free spectrum because nobody yet is using it.
同时它可以达到非常高的传输速度，以及现在因为没有其他人使用它。
So let's talk about wireless modes for 60 gigahertz.
现在我们来讨论一下60G 赫兹的无线模式。
Before latest current version 641, there were different modes
在6.41版本中，现在我们有一些新的模式。
named slave and master.
在以前我们叫主 master 主模式和 slave 从模式。
Right now they're renamed to match existing MikroTik wireless modes.
现在它们被改名以和其他 MikroTik 的产品的命名相符。
Access point bridge mode supports more than one connected client. Access point bridge mode allows you to host more than one client.
OK，AP Bridge 模式允许你同时连接多个客户端。
Bridge mode limits it to one connected client.
Bridge 桥模式只允许连接一个客户端。
Station bridge is for clients.
Station Bridge 是把这个设备当做客户端使用的。
And sniff mode is for sniffing traffic.
Sniff Mode 是用来去扫描周围的流量的。
All configuration is done under new menu interface V60G.
所有的新的配置选项都在新的 W60G 菜单下面。
Minimal configuration is same SSID, same password, and correct modes.
最小配置需要配置 SSID 密码和模式。
So, this is how it looks. This device is sold as a kit. It's 2 devices for one price.
这个设备是成对出售的。
It's a pre-configured 60 gigahertz radio link. You just plug and play.
每一对设备都已经在出厂前被预先设置好了，你拿到设备后，只要插上后就可以使用。
It's a first MikroTik wireless device coming with already set password on wireless interface.
这是 MikroTik 第一款预设有 WiFi 密码的设备。
It's equipped with ARM-based 4-core CPU running at 760 megahertz.
它是基于一个4核的处理器，运行在716兆赫兹的频率。
Before S60 AC came out, this was the fastest wireless device made by MikroTik
在60G 出现之前，这是 MikroTik
by means of
最快的设备。
CPU performance.
在 CPU 速度来上讲，这个是最快的设备。
It only needs 5 watts of power on max load.
同时它只需要5瓦的最大输出功率。
Range for this device is 100 meters or more.
这个设备的无线距离范围是100米甚至更远。
People usually ask, what does 100 meters plus on 100 meters and more mean?
人们通常问100米加100米或者更多是什么意思？
In most setups in 100 meters, it should provide full gigabit duplex speeds. So basically, it's 2 gigabits per second at 100 meters.
在通常的配置上讲，100米的范围我们能提供总共2GB 的传输速率。
It's our first device supporting beamforming, and it also supports point-to-multipoint.
这是 MikroTik 第一款支持波束成型以及点到多点的设备。
Channel bandwidth is 2.16 gigahertz, so those are very large channels.
这个设备的频段宽度是2.16G， 是一个非常宽的频段。
Currently, there is 3 available channels.
当前有3个可用的频段。
Antenna gain for this device is 13.5 dBi.
天线增益是13.5 dBi。
And total ERP is under 40 dBm.
总输出功率是45 dBm。
There's one antenna on board with 32 active antenna elements.
整个主板上有一个天线，但是有32个天线小元素。
So this is the most complex antenna from MikroTik yet.
这是目前从 MikroTik 生产的最复杂的天线设备。
Device does frequency sweeps. Device does beamforming sweeps in background, checking for best element to use, best antenna pattern to use.
设备会在后台使用波束成型以及扫描最好的天线配对方法。
So it's equipped with 60-degree antenna, but because of beamforming, it could cover pretty much close to 180 degrees. Just read.
这个设备由于感谢波束成型，这个设备最大可以覆盖180度的范围。
And price for it is $198.
官方建议售价是198美元。
This price is for 2 devices.
这个价格是对一对设备的价格。
So we did a quick comparison with other MikroTik devices in terms of wireless performance.
现在我们和 MikroTik 其他无线产品对比一下性能。
Yes, higher speeds could be achieved, but those were done in real network environments.
在实验室环境中其实是可以达到更高的速度的，但是这些速度是在实际环境中可以达到的。
So 60 gigahertz is not limited by radio performance, but limited by Ethernet performance.
60G 的速度限制并不是由无线限制的，而是由有线速度限制的。
That's why we called it wireless wire.
这就是为什么我们叫它无线的有线设备。
And this makes it price performance sweet spots for very short links.
这个设备为短距离的无线传输提供了非常好的价格性能比。
At some cases, it's even cheaper to drop a cable to pay for installation.
有时候它甚至比付费安装一条有线线路更便宜。
So this Winbox screen shows 2 gigabits per second speed. So 1 gigabit per second is throwing one way, and 1 gigabit per second is throwing the other way.
这个性能测试截图显示了，在双向上每一个方向都可以达到1G 的速度。
This one is from real 100-meter link, currently in Latvia.
这个测试是在真实环境下的100米测试达到的。
So we did some tests to compare wireless performance with cable performance.
现在我们来比较一下无线和有线的速率比较。
We connected 2 PCs with Ethernet cable.
我们测试对比对象是使用有线的电脑。
And we run different tests between them to compare how it performs compared to wireless wire.
我们会运行多种测试来和有线设备进行对比。
As you can see, it falls a bit short only on small packets.
你们可以看到，在使用小包的时候，它的结果是比较低的。
Other than that, it provides same performance as Ethernet cable.
在包越来越大的时候，你会看到它能提供和有线一样的性能。
We did UDP tests, and we also did TCP tests.
我们运行了 TCP 和 UDP 的测试。
We also added point-to-multipoint support.
我们同时添加了点对多点的支持。
This means that one access point can support 2 connected clients.
这个意味着一个 AP 可以连接2个客户端设备。
Experimental support started from version 641.
实验性的支持从 6.41 版本开始。
So if you upgrade your router to latest current version, you should be ready.
如果你把你的路由器升级到最新的版本，你就可以开始使用它了。
Only limitation right now is that the devices come with level 3 license.
唯一的限制是那些使用 L3 授权的设备。
So license upgrade is required.
L3 授权的设备需要升级到至少 L4 授权。
Connected clients are treated as individual interfaces.
每一个连接的设备都会当做一个独立的接口显示在里面。
It makes much more easier for configuration
这个会使得配置变得更加简单。
and allows additional option for scriptings.
同时会提供附加的加密选项。
Currently, 8 connected clients are supported.
目前我们支持最高8个客户端同时连接。
So we want to test coverage with point to multipoint.
现在我们来测试一下点到多点的覆盖情况。
We set up 2 clients, connected them to access point.
我们设置了2个客户端连接到一个 AP 上。
Distances were close to 100 meters.
所有的距离都是和100米非常接近的。
First and second columns shows distance in meters.
第一列和第二列的距离是单位是米。
Third column shows distance between clients.
第三列是显示两个客户端之间的距离。
So we could achieve 200 megabits full duplex for each client.
对于每一个客户端，我们都可以达到200兆的双工速率。
And we could get to 124 degrees of coverage.
我们最大也可以达到120度的无线信号夹角。
Actually, we could get more, but we ran out of space.
实际上我们可以达到更多，但是我们的办公室大小有限。
Latvia is a small country.
拉脱维亚是个很小的国家。
So this screen shows 4 connected clients receiving the same 200 megabits full duplex.
这个截图显示了4个客户端，每个客户端都有最高200兆的速度。
So basically, it's 400 megabits per client.
所以就是每个客户端200兆。
So in the latest current version, we did some changes for V60G.
在最新的版本里，我们对 W60J 做了一些修改。
Before 641, as I said previously, modes were called master and slave.
在6.41版本之前，我们把这些设备叫主设备和从设备。
Right now, they have the same naming scheme as other MikroTik wireless devices.
现在它们的命名和其他 MikroTik 无线产品的命名都差不多。
We added put slaves in bridge and isolate slaves options.
我们给然后我们现在把这些 master 和 slave 选项改成了和其他无线设备类似的 bridge、AP bridge、station bridge 模式。同时，我们把那些从客户端放到了桥，添加了把从客户端放到桥里，以及从客户端隔离模式。
Also, right now, it supports data rates under MCS4.
现在还支持了更好的 MCS4 速率。
What does it mean?
这意味着
right now you can connect with a lower rate. You will suffer in speed, but you can increase the distance.
你可以以牺牲速度来换取更远的传输距离。
In Latvia, we have newly created link over 200 meters of distance.
在拉脱维亚，我们最远达到了200米的距离。
It's working fine. There have been no disconnections for half a month.
它工作的很好，在半个月时间内没有出现任何断线的问题。
And weather in Latvia is much worse than here in China.
但在拉脱维亚的无线信号比中国要差很多。
So range is increased for over 200 meters.
所以最后无线传输距离可以达到200米以上。
We also added SNMP support for gathering data about V60G interface.
在最新的版本里，我们同时添加了 SNMP 功能，去让其他设备获取 W60J 设备的运行状态。
So currently you can use SNMP to get SSID, to get used sector for transmit, used sector for receive.
所以现在可以用 SNMP 获取到 W60J 的 SSID 发送以及接收速率。
And you can also use it to monitor signal quality and data rate used.
你也可以拿它来监控信号质量。
So let's talk a bit about wireless device testing.
现在我们来谈一谈无线设备测试。
We in support get a lot of mails about my virus device is not performing as I expected.
我们收到了很多邮件来投诉测试的速度达不到标称的速度。
Most of those tickets is caused by testing it a bit wrong.
绝大多数都是因为使用了错误的方法去测试。
So there are few suggestions to avoid common mistakes.
所以接下来是几个建议，防止出现配置上的错误。
It's preferred not to run testing tools on devices you are testing.
首先不建议你在你要测试的设备上运行测试。
So if you're testing virus bridge, you have to make testing setup over that bridge.
比如说，如果你要测试一个桥的性能，你需要在这个桥上连接2个设备去测试，而不是在桥自身上去测试。
Always check for bottlenecks.
同时要检查一下瓶颈。
Because sometimes it's a CPU because of testing tool running on board or Ethernet interface, for example.
有时候是因为 CPU 速度太慢，有时候是因为直接在端口上运行了测试。
Virus devices suffer from interface very much.
同时无线设备会受到各种各样的干扰。
Don't test 20 devices on same frequency on same room.
不要在同一个房间的同一个频率上进行测试。
Tested power outputs that will be used at the device and distances should be the same as you plan to implement your link.
在测试时，你的输出功率应该和你正常想用的功率是一致的。
So let's talk about a bit software used for testing virus links.
接下来我们来谈一谈测试用的软件。
If you are testing a throughput with bandwidth test, you should remember that it uses CPU resources a lot.
如果你要在RootOS 里使用 bandwidth test， 这个测试会消耗大量的CPU。
Single bandwidth test instance will run on single core.
每一个宽带测试只会在 CPU 的一个核心上运行。
So if you are testing virus wire with bandwidth tests, you are actually testing one core performance of virus wire.
所以，如果你要在无线设备上运行宽带测试，你实际上是在测试这个单核 CPU 的性能。
I saw the same mistake today.
我今天还看见了一次这样的错误。
So traffic generator, it's a bit more advanced tool.
Traffic generator 流量生成器是一个更高级的测试工具。
It works on router OS, and you can gather much more data about tests.
它是运行在 RootOS 上的，同时你也可以获取到更多测试数据。
iPerf and iPerf3 could be run on Linux, Mac, or PC machines.
iPerform 和 iPerform3 是可以运行在 Windows、Linux 和 Mac 电脑上的。
But there's some drawbacks in iPerf3. I dislike, for example, dual streams on both ways.
无线设备是单工设备，它不能同时发送和接收数据。
You have to open different servers on both sides and different clients on both sides.
你需要在两端分别开多个测试程序去测试。
There is also speedtest.net, but I never suggest this device for testing virus performance.
你也可以用 speedtest.net， 但是我个人不建议用这个做性能测试。
It could be bottleneck somewhere else, as well as your internet service provider may.
可能多个地方都会有瓶颈，比如说你的宽带接入速度。
Your internet service provider may use it not very correctly.
你的网络供应商可能会有一些其他问题。
There is also other tools for bandwidth testing.
同时也有一些其他测试宽带的工具。
So let's jump in testing.
所以现在让我们来做测试。
My colleagues always say, never do live tests.
我的同事说，永远不要做现场演示。
Never do live tests with virus.
永远不要在现场做无线演示。
Never do wireless tests with USB Ethernet adapters.
永远不要使用 USB 网卡做测试。
So today we are for a rough ride.
然而今天我们要打破这些所有的。
Also, I previously stated never run bandwidth test tools on devices.
同时我要打破不要在设备上运行速度测试。
Today we will do all the same things
今天我们要把所有的事情都做了，
and check what works, what doesn't.
然后来看一看什么是工作，什么是不工作的。
So, traffic generator tool uses CPU resources very equally.
Traffic generator 工具会平等的使用 CPU。
For example, you can set two IPs from same subnet on two devices,
比如说，你可以在里面设置同一个子网的2个 IP 地址，
and you can send the same traffic stream to transmit and receive it back.
所以你可以在测试工具同时设置发送和接收。
This way of testing allows to check packet losses. This testing can show possible packet loss.
所以这个测试可以测试尽可能的测试出来效果。
Because you are generating packets and you're receiving the same packets back.
因为你是在生成一个数据包，同时接收同样的数据包回来。
So if transmitted count doesn't match received, you have a packet loss.
所以所以如果你发送和接收的数据包数量不一致，就说明你中间出现了信号丢失。
So let's open Winbox.
现在我们打开 Winbox。
So in front of me, there is one access point.
现在我面前是有一个 AP。
And on the table at right, there are two clients.
在对面的桌子上有2个客户端。
In real life testing with wireless wire, never put clients so close.
在真实的环境中，我们永远不会把无线客户端放得如此之近。
There is no need for such small distances for two clients to be connected to access point.
如此近的距离不需要放2个客户端设备。
So let's talk about bit commands run. So
现在来谈一谈，聊一聊测试用的命令行。
with traffic generator, at first you create packet template.
在 traffic generator 里，你首先生成流量模板。
IP destination in this case is the same device sending traffic.
IP destination 在这个测试里就是发送信号的设备。
IP gateway is the device on the other end.
IP gateway 是对面的设备。
IP source is random unused address from same subnet.
IP SRC 是在这个子网里的其他设备。
Why? Because you have to make layer 3 protocol happy.
Sorry?
That's for layer 3 protocol. Layer 3 protocol. It's for IP protocol to work.
只有这种方法才能最好的测试 IP 协议。
You could also add more ports to simulate multiple connections.
你也可以同时选择多个端口来测试多线程。
After that, you make stream that uses the same packet template.
接下来你创建一个 stream 来使用这个模板。
You can set speed, you can set packet size.
你可以设置速度，也可以设置包大小。
And you are ready to test.
接着我们就准备测试了。
So I'm also setting a stream name because I have also created second stream for second device. And
我
right
现在要
now
创建第二个设备的流明，因为我还有第二个设备要测试。
we will try to send 400 megs and try to receive the same amount back.
我们现在设置400兆的发送速率以及400兆的接收速率。
So here everything is working and we can open graph to see.
现在看起来所有设置都是正确的，我们来看看流量图。
So this is 8 megabits per second over air.
现在这里就是总共800兆每秒的速度，使用无线设备。
So we can increase the speed
我们可以继续增加速度，
to, for example, 900 megabits.
比如说900兆，
That's 1.8 gigabits per second.
这就是接近1G 每秒的速度。
So here you go. That's a single client connected. Sorry, there are two clients connected, but it's sending to one client.
现在我们这个测试我们有2个设备连接，但是我们只和其中的一个设备在进行测试。
We can also run the same test, but with two clients.
我们也可以在2个设备上同时运行同样的测试。
Let's start with smaller values of speed.
我们先从比较小的速度开始。
Let's increase speed. For example, 400 megs.
接下来再把速度增大到400。
So this is basically 800 megabits per second for each client.
所以现在是基本上800兆的，每个客户端800兆的速度。
So this is client 1. This is client 2.
这是2个客户端分别的流量图。
So you see, speed is stable, everything is working.
现在可以看速度很稳定，所有东西都按预期工作了。
If I go through the link, it
如果
should
我站到2个设备的中间，
it should drop for some small time, small amounts of traffic. If I stand longer, beamforming capabilities will find another way around me. So
如果我站2个设备中间，它会有一小段时间的流量下跌，但是感谢波束成型，它会寻找一个更好的路径来进行传输。
So let's talk about a little bit commands used. You can start traffic generator with start.
现在来谈一下我们使用的命令。首先，你可以使用这个命令来启动traffic generator。
And you can stop it with stop.
你也可以用 stop 命令来停止流量生成器。
It's preferred to use smaller speeds at first because traffic can go somewhere else and you can lock yourself out.
首先建议你从比较小的速度开始，因为这个流量可能会到其他地方，导致你被锁在外面。
You still need powerful hardware to run this test, but wireless wire is more than enough for this task.
你也许需要更强劲的硬件来运行这个测试，但是wireless wire 这个设备是可以的。
There is also a possibility to check with different packet sizes and add time for tests.
你也可以使用不同的包大小来进行测试。
For example, if we need a small packet performance,
比如说，我们现在测试一下小一点包的性能。
and we are getting the same speed through link with smaller packets.
我们依然得到了同样的性能测试结果。
And we can check CPU usage.
我们可以来检查一下 CPU 使用率。
So right now we are just using 76% of CPU.
目前我
We
们
are
只
sending small packets to two clients and receiving the traffic back.
目前我们只使用了76%、77%的 CPU，我们这是在进行小包测试。
On full wing load with large packets, CPU usage will be still very low.
在使用大包测试的时候，我们的 CPU 使用会非常的低。
So you have a large headroom for your setups, for your intended use of this product.
所以你还有很多资源剩余。
So this is a setup. If you need, you can copy commands. Slides will be available at mom.mikrotik.com.
这是3个设备的设置，你可以拍个照。这个演讲的 PPT 稍后也会在网上可以下载。
Thank you for your attention. Maybe somebody has some questions?
有人有问题吗？
No questions? Thank you.